All right, so today we're going to do number 24, linear and nonlinear. This goes along with your textbook and workbook pages that you did last Monday and Tuesday. Now, for my virtual people who are watching, number 23 you won't have, but just go ahead and skip number 23 and put number 24. You won't do your turkey functions at home. So 24, and today's the 30th. Okay. So linear and nonlinear. Does anybody remember anything from the textbook or workbook pages that you can tell us about linear and nonlinear? All right, Ann, at it.
Linear has to have a constant rate of change.
All right, so linear has a constant rate of change. Yes, ma'am. Let's write that down. So constant rate of change. That's what makes that straight line. Okay. All right, so what does that mean for nonlinear? Yeah, right. The rate of change varies. The rate of change varies. All right, so let's first talk about when we have equations, what it's going to look like and how we can tell whether it's linear or nonlinear just from the equation. So let's just make a little chart, give some examples. Of course, this won't be all of them. I can't list them all, but it'll give you enough. All right, so we're going to have linear on one side, nonlinear on the other. So she said that the linear has a constant rate of change. So it's just going to look like y equals x, or y equals x plus 2, or maybe y equals 3x. It's those basic equations. I believe in your book, I think it was in the workbook that we talked about it, that if your equation can be written in the form of y equals mx plus b, then it's going to be linear. Okay? Let's put a few more examples. I could even had a fraction. I know most of our rates of change so far have been whole numbers, but we usually do have more fractions as our coefficient of x when we get to the graphing part. And then, of course, we have that plus or minus number. What is that plus or minus number? That's our what?
Initial value.
It's our initial value, which is also our what if we're graphing it?
Y-intercept.
Our y-intercept. Okay. We could even have it, we haven't really seen it yet, but it could be set up like that also, where it's just y equals x divided by 4, because that's the same thing as y equals 1/4 x. Okay. We could even just have y equals 2, because if you don't have an x in the problem, then what would your rate of change be? 0, because if there's no x, there's 0x, so we don't write it down, so we would have a rate of change of 0, which would make a flat line. That's those horizontal lines. We could even have it where it was x equals, let's just say 3, and when we're missing the y, we only have the x. That's when we have a vertical line. Okay? So all of these, you could kind of characterize it. We like to say that they just have a plane x. Those are our linear, okay? And that's where we say it. Our technical description would be that the degree of x is not larger than 1. And degree means your exponent. Okay, so you're only going to have, remember, if you don't see an exponent, there's a 1 there, understood? So if I have any powers of x, then we're going to be looking at nonlinear. Okay, so if it's just a plain old x, like we're used to seeing, those are linear. So nonlinear, if I had y equals x squared, and I know there was at least one in the work that you did, I believe, on Tuesday, because I think that's the one I did. I talked to you about the x squared. I mentioned to you would be a U-shaped graph, and we'll get more into that in just a little bit, what that looks like. If we had y equals x to the third, okay, that would be nonlinear. I could have had negative x to the third, still nonlinear. There could be a square root of x. Anytime you have something different like that, that's going to be nonlinear. And we'll talk about in the coming days for you what that square root's going to look like. If we have x on the bottom, that becomes nonlinear. Okay, x on top is fine, but x on the bottom is nonlinear. And if we have any absolute value bars, that's also nonlinear. And like I said, this isn't all of them, but these are the ones that you see mostly. But if you can just remember, if you have a plain x, that's linear. If we have a fancy x, that's nonlinear. So something's going on with the x, so it's fancy. Everybody wants to be fancy. Then it's nonlinear. Uh-huh.
Does it also count for y being squared?
You won't have any of those. We'll just have y, because if you have y squared, you're not complete with the problem, because y's got to be by itself. It's got to be singular, because if you had y squared, you've still got something to work out. You know what I mean? Okay. All right, so that's if we're just looking at the equation. All right, let's look at what the graphs look like. Graphs are pretty simple. If it's straight, it's linear. If it's not, it's nonlinear. So let's just look at some examples. Of course, that's easy enough. Let's see, I'll give you this one. That is actually what x cubed looks like. So that's nonlinear. I'm going to move, if you've got room, you can keep writing, but I don't have a lot of room down here, and I've got you some more graphs to get, so I'm going to flip it. All right, I mentioned to you that x squared is a U-shape. That's called a parabola. So x squared is a U-shape. If I'd had negative x squared, then we just flip that U over. Now notice my, for x squared and negative x squared, the bottom of the U, my minimum, or the top of the upside down U, my maximum, those are going to hit right on the origin. Because if it had been like x squared plus 2, that plus 2 still would have told you where on the y-axis it would have hit. Or if it said minus 2, it would have shown you that. So the plus or minus number is a shift up and down the y-axis when you have a parabola. Okay. And if we had absolute value bars, that actually gives me a V shape. And same thing, I didn't have any plus or minus out here, so I put the bottom of my V right on the origin. And later in the year for you, we'll get into it a little more. When we have coefficients of x, that's what makes the V get wider or the U get wider or get narrow. That all affects the shape of it. But these are just the general, this is what it looks like. If I had negative on the outside of the bars, and I got my upside down V. And let's see, let's go ahead and include, because I gave you the x cubed, so what do you think negative x cubed is going to look like? Yeah, it's just going to go the other way. So let's see if we can get one of those. So instead of going this way, we go that way. Would be our negative x cubed. But the x squared and the absolute value, that's the ones that you'll see the most of. And just to know, get a picture in your mind, that will help you. All right, now, last thing we'll talk about are the tables. We have to also be able to tell if the table is linear or nonlinear. So if we're wanting to know, that's really just asking, is the rate of change constant? Is the rate of change constant? All right, so let's try out some tables. All right, so if we want to find the rate of change from a table, what do? What are we looking for? So the change in y over the change in x. So delta y over delta x. All right, so, and you got to look for it, you got to make sure it's every time, not just look at the first couple, because we're asking, is it constant? Okay, so they may wait to the bottom before they throw something in there. So what's happening on our y's every time? Yeah, every time it's adding 2. Our x every time is adding 1. Okay, so our rate of change is 2 over 1. So yes, we are linear. All right, let's look at this one. So I've got 1, 1, 2, 2, 3, 6, and 4, 24. All right, so what's happening on my y? Added 1, and then added 4, and then added 18. Now, you can't rule it out automatically because you have to check the other side to make sure that maybe these fractions aren't going to reduce down to the same number, because sometimes they'll skip a chunk of numbers and that's still okay. So we have to check the x, but x is adding 1 every time. They stayed consistent over there, so it's not the same, so we would just be nonlinear. We could graph it, but it's not going to give us a straight line. That's what we want. Let's see, I'm going to go to the next page. So I have room. Now, I'm going to give you 6 tables to try. All right, and if you're virtual, stop the video, do the tables, and then rejoin. All right, so let's look at number 1. So what's my, Trinity, what's my Y doing?
Increasing by 4.
All right, it's increasing by 4. All right, Marisol, what about my X?
Increasing by 1.
All right, so Riley, what does that mean for my rate of change? Yes, it is linear, because what is my rate of change, Riley?
4.
Yeah, 4/1, so I'm going to give that an L. All right, let's see, Kane, what about Y on number 2? What's my Y doing?
It's going up by 2, and it goes up by 3, and it goes up by 4.
Is it going up?
Oh, it goes down.
Yeah, it's going down by 2, down by 3, down by 4. What's my my X doing? By 2. Yeah, every time. So is that constant? No, so that is nonlinear. Give that the N. All right, let's see. Paisley, what about 3? What's my Y doing? All right, it's increasing by 4 every time. Okay, Grayson, what about the X? Decreasing by 2 every time. So what is my rate of change, Grayson?
The rate of change is negative.
Yeah, because it would be 4 over -2, which is -2. So am I linear or nonlinear? Linear. If you can find the rate of change, it is linear. How many got the first 3 correct? Awesome. Okay, good. All right, let's see. Angie Jane, what about number 4? What's my Y doing? Do what? 0. Yeah, it's not changing at all. Eli, what's the X doing? Yeah, so it's a little up and down, but am I going to be linear or nonlinear? How much? How many say nonlinear? Well, some of you. How many of you say linear? What does 0 over -2 equal? 0. What does 0 over -1 equal? 0. What's 0 over -2 equal? 0. So it is linear. It would actually be a horizontal line. That's what those graph out to be. So yeah, that one is linear. Okay. All right, then what about number 5? Michael, what about the y's?
It's 5.
Yeah, and then let's see, Will, what about x? Decreasing by 3. So Kelsey, what does that mean my rate of change is? It is linear, and what is the actual rate of change?
5 over negative.
Yeah, so negative 5/3. How many got number 5? Okay, good. And Savannah, what about y on number 6? What's the y doing? Okay, and what about the x? All right, so do you think linear or nonlinear? How many think nonlinear on this one? Some of you. All right, so Savannah, what is the rate of change on this first part? Yeah, well, the rate of change on this first one would be 2 over 1, right? And then the second part is 6 over 3. But what does 6 over 3 reduce to? 2. So is it linear? Yes, because they both reduce down to 2. That's what I was talking about. If they skip some chunks of numbers, sometimes you got to make sure, oh, does this reduce to what the other one is? You kind of have to be careful there. They'll get you sometimes. How many got all 6 correct if you had time to get all the way through? Okay, all right, not too bad. Now, tomorrow we'll do some more tables of you doing the rate of change, linear, nonlinear, that sort of thing. All right, good job.